Assalamualaikum and a good day to all of you. So this is lecture 1 part 2. So I will talk more about um, local area network. So what is local area network? So in order to understand about local area network, we need to understand two main criteria of local area network. Which is the first one is a local area network is a collection of connected devices in a single limited area. Okay, connection of connected devices in a single limited area. So this is the main difference between local area network with wide area network, where in a wide area network, the networks span across uh, a large geographical areas. Okay, so when we talk about a local area network, we need to talk about the need to scale the network. So basically a company with a small network with one site. So when we say one site, it means that a single location, like for example here like in Osaka, Boston, Orlando. So basically a company with a small network with one site and a connection to the internet might grow into an enterprise with central location with numerous remote sites across the globe. So for example, if your original company is in Orlando, so your company can expand and have several branches all over different location across region. So all enterprise network must support the exchange of various types of network traffic and must support critical application, must support converged network traffic, must support diverse business needs and provide a centralized administrative control. So the LAN is the networking infrastructure that provides access to network resource for end users over a single floor or a building. So basically, when we talk about the local area network, we will talk about first based on the home and small office internet connection. So let's see the differences here. When we talk about it start from the home and small office internet connection. So at home network you have home user or teleworker. So teleworker is the worker that connecting to their main office from home. For example, if you are working from home, so you will be called teleworker, and working from home and access the resources of your organization, so you'll be called as teleworker, and also the small office here. So this is the type of connection that you may use. For the home user, you might use DSL and also cable, or you can use cellular, and also you can use the satellite. For the last one, the dial-up telephone, we rarely use it anymore because nowadays most of the home or small office has switched into the DSL connection. So the corporate business connection may require higher bandwidth, dedicated connection and managed service. So if you look here, the type of connection differs from the home and small office internet connection. Okay, so in the business internet connection, we will use dedicated lease line, metro internet, and also business DSL and also satellites. So the dedicated lease line is the reserved circuit within the service provider network that connect distant offices with private voice and data networking. So basically what happened here, the organization or the business will subscribe or lease the dedicated line where we have the ISP will provide guaranteed bandwidth from the organization to the internet provider. So in growing complexity of the networks, we need to talk about the next gen network, where the next gen network need to be secure, reliable, and highly available. So they need to also must be able to integrate legacy devices because we know that from the beginning, the expansion of the company always starts from a long way. Yeah, so basically, in the beginning they might use some of their legacy devices, but when you are expanding your company, so and buying a new equipment, so we need to find a way to integrate the newer equipment with the old one. So that's why it is important for us to learn or to understand about the converging network. So before converged network, so an organization would have been separately cabled for telephone, video and data. So the company, most of the organization has been around like 30, 40 years ago. So basically they have set up their own network. What but in the old or traditional network, the all of the arrangement or network infrastructure may be separately cabled. For example, for telephone, video, and also data. So each of this technology would use a different set of rule and standard. So the diagram shows that in the past, computer networks telephone networks, and broadcast network operated separately. So each network used its own devices, transmission media, and also standards. So this requires separate infrastructure for data, voice, and voice, and also video communication. So today, these services can be carried over a single converged network, which may reduce the cost and complexity. So what converged network is by integrating all of these different network devices or transmission medium so that they can combine data, voice, and video service on the same network infrastructure. So here is how the converged network looks like. So the converged network will integrate voice system, IP phone, voice gateways, video support, and also video conferencing. So the primary benefit of the converged network is to just one physical network to install and manage. So in the converged network carry multiple service on one link, including data, voice, and also video. So meaning the transmission medium can the same transmission medium can deliver data, voice, and video over the same network infrastructure. So the network infrastructure use the same set of rule and standard. So basically in this diagram, we have the rule agreement standard, which refers to the set of protocols and standards that devices must follow to communicate successfully. So next we have these technologies, which is borderless network. So borderless network has the following features, which allows organization to connect anyone, anywhere, anytime on any device. So the borderless network provides framework to unify wired and wireless access. So in the converged network, uh, the converged network, what it does is it combines different network solution to integrate transmission of voice, data, and also video. But in the borderless network, it's to provide a unified wired and wireless. So basically, what they integrate is including the policy, access control, and performance management across many different device types. So it will provide our services and users and endpoint services that are all managed by an integrated management solution. So in the borderless switch network, there are hierarchy. Like I mentioned earlier on, borderless network is to combine or unifying the wireless and wired. So in the diagram, we can see that borderless switch network design are based on the following principle, which is the first one is the hierarchical, means that it needs to facilitate understanding the role of each device at every tier. So we have three tier here, which is access layer, distribution layer, and also core layer. So we need to understand the role of each of the tier. And then modularity, which allows seamless network expansion and integrated services. And resiliency, which provides an always available network. And lastly, flexibility allows intelligent traffic load sharing. So let us look at the function of each layer in the borderless hierarchical network. So in the first layer, we have the access layer, which provide network access to the user. So if you look here, so we in the access layer, these are the equipment which is LAN switch that provide network access to the user. So to the user here means the end devices, which is the PC, the IP phone, and also the um, mobile devices. So in the distribution layer, it interfaces between the access layer and the core layer. So it provides functions such as aggregating layer 2 broadcast domain and layer 3 routing boundaries. So this is the part where we have the distribution layer. And then it provides intelligent switching, routing, and network access. So, and the core layer is the network backbone. So it provides fault isolation and high-speed backbone connectivity. So if we look here, so the diagram here is much more clearer on what type of devices should be on the access layer, distribution layer, and also the core layer. So the smaller network that do not need a separate distribution and core layer often use a two-tier campus or collapsed core network design. Meaning here, traditionally, we will have three layer of three hierarchy of borderless switch network, which is access, distribution, and core. But in a smaller organization where maybe you only have one building, so basically the function of core layer and distribution layer is combined. So we do not separately differentiate the layers between core and distribution. We just call it as collapsed core layer, where you combine the distribution and core layer together. So in the hierarchical switch LAN, it allows more flexibility, traffic management, and also additional network. So if you see here in the middle, the function of devices has been divided according to the layer. So next, let us talk about the protocol suite. So network protocol is defined as a common set of rules that govern communication. So you can implement the network protocol on devices in on the software part, hardware part, or also both. There are several types of protocol, which is the first one, network communication, second one, network security, the third one is routing, and last one is service discovery. So for a protocol that falls under network communication part, is the function is to enable two or more devices to communicate over one or more network. For network security is to secure data to provide authentication. For routing, it enables router to exchange route information and compare path information, and finally select the best path. So what are the network protocol functions? So basically, any devices will use the protocol to agree upon protocol to communicate. So in order for two devices to communicate to each other, they need to agree to certain network protocol. So protocol may have one or more function, which is sometimes we use like for example protocol that we use for addressing, so we use IPv4 or IPv6. And then we have the reliability we use TCP or UDP. And then flow control, sequencing, error detection, and application interface. So the diagram here shows a message being sent from a computer to a server through a multiple routers. So all devices, so it says here, okay, the end user say that the end devices say analogically say that I will send this message across the network using an IPv4 header. So what is the protocol that we use here? So it is IPv4. So since the end device here are using IPv4, the server also need to use IPv4. So all devices must understand and can understand the IPv4 header, allowing the message to be forwarded correctly across the network. So basically, protocol provide the rules that enable devices to communicate with each other. So the protocol must be able to work with other protocol. So that's why we have a protocol suite. So protocol suite is a group of interrelated protocol which is necessary to perform a communication function. So where you have a set of rules that work together to help solve a problem. So basically, in terms of layer, the protocol can sit on the higher layer or also the lower layer. So in this diagram, uses the human conversation to explain how network communication, how network protocol works. So we have here the content layer where the actual message being communicated, for example, where is the cafe? And then we have the rules layer where the rules that both people, which is person A and person B, need to follow to communicate effectively. So basically, they need you to use a common language, take turns speaking, signal when the conversation is finished. And then we have the physical layer, which is the medium that carries the message. So in the diagram, the medium is spoken words between two people, but in a network, because in the diagram is like two persons talking to each other when the first question is where is the cafe. But in the real world, in the network, it can be cable, fiber optic link or wireless signal. So basically, just as a human need a rules and common language to communicate to each other, the same goes or the same idea will need to be applied to the network devices. So layered model, so earlier on, I have explained that protocol must be able to work with other protocol, and then we will have the protocol suite, which a group of interrelated protocol to perform communication function. So in the protocol suite, do we have the layered mode? Which was created to address communication incompatibility and the complexity of the diverse networking protocol. So the most popular reference model is OSI reference model, which is created by the ISO. So OSI reference model has become the basis for many data communication standard. However, OSI ni, OSI, you have learned OSI in data communication subject, data communication and networking subject. While OSI is a theoretical model and not widely used in practical application, but it is fundamental for understanding network communication concept. But in real life, we do not use OSI ataupun in practice, we do not use OSI reference model. We use TCP/IP model, TCP/IP reference model. So this is the benefit using layered model. So you just can read it yourself. So like I said, the in practice we use TCP/IP Internet Protocol Suite, which is the protocol suite is maintained by the IATF that I have mentioned in the previous video. And then we have the OSI that you have learned in Datacom subject, and then we also have other protocol suites like Apple Talk proprietary suite, which is for the Apple devices, and also Novel NetWare, which is proprietary suite for the Novel Incorporation. So in here you can see that the differences in terms of what kind of protocol that we have for each layer, but all of the protocol here is mapped into the general guideline of the TCP/IP layer. So what we want to see is in each of the different protocol suite, what are the protocol that is used on each layer. So for example, for TCP/IP on the application part, one of the common protocols on the application layers are HTTP, DNS, JCP, FTP, and then for transport we have TCP, UDP. For internet we have IPv4, IPv6, ICMPv4, ICMPv6, and then network access we have Ethernet, ARP, and WLAN. So if you look into others, these are the proprietary protocol for each of the proprietary protocol suite. Proprietary means the protocol or the protocol suite can only be used by the devices from the same manufacturer. Okay. So if you look here on the network access part, in order for all of the different protocol suite to talk to each other, they have the common protocol for the network access. So the benefit of using a layered model is a networking model is only a representation of the network. The model is not the actual network, but it will break down the complex concepts such as how network operate can be difficult to explain and understand. So has the reason why we have the layered model used to form an understanding of how each of the protocol works across different layers in the reference model. So basically here you can see that for the OSI, application presentation and session is the same. The protocol is combined, integrate together into one single layer in the TCP/IP model, and then we have the rest like what you see here lah. Okay. Okay, so the TCP protocol suite does not specify which protocol to use when transmitting over a medium. So that's why you can see here OSI layer 1 and 2 will discuss the necessary procedure to access the media and the physical means to send the data over network. So TCP/IP is the protocol. Okay. Now because like I said, in practice we use the TCP/IP protocol suite. So TCP/IP is the protocol suite used by the internet and includes many protocols. So TCP/IP is an open standard protocol suite that is freely available to the public and can be used by any vendor. So a standard-based protocol suite that is endorsed by the networking industry and approved by a standard organization to ensure interoperability. So here you can see that a much more expanded, a much more expanded network protocol being laid out. Yang the one that we have here is only a brief one. Okay, it's not an example, but this one is much more extensive according to type of the service, and this is only the more popular or more common services. Of course, we have lots of other network services, like for example name system, we have DNS, and then host config, we have DSPv4, DSPv6 and Slack. And the email, we have SMTP, POP3 and IMAP. File transfer, we have FTP, SFTP and also TFTP. And web service itself, we have HTTP, HTTPS and also REST. Under transport layer, it divided into two if the connection is connection oriented. So we use TCP and protocol, and if it's connectionless oriented is we use UDP. The rest is so on and so forth lah. So basically here, like I said, this is the importance of the protocol suite, which is to guide. It is to guide the complex concept as how the network operates, which previously very hard to understand. So basically here, by breaking down according to layers, it will make the network practitioner to easily understand the complex operation of the network communication. So for the TCP communication process, a web server encapsulating and sending a web page to a client, and a client will de-encapsulating the web page for the web browser. So for example here, for the web client, okay, web client request for something, like for example, the request for opening a website. So the web server will encapsulate. Okay, if you see here, this is the layer 2. Okay, this is layer 2, or basically in TCP/IP is layer 1. Okay, so here is the Ethernet frame. So on the in the packet, or we call it frame, okay, because it's in network access network access layer. So the header is the Ethernet MAC address. Okay, the MAC address of the devices and followed by IP. So Ethernet here is layer 1. I'll go back here. Ethernet here is layer 1. And then IP is layer 2. Here, Internet Protocol, layer 2, Internet layer. This is how we read it. And then TCP is layer 3, transport layer. And data is user data is layer 4, application layer. So when you send a frame across the network, so basically the frame will be encapsulated and then the frame will be break down into several fields that constitute each layers in the TCP/IP protocol, TCP/IP suite. Okay, so and the client, when they receive, they will de-encapsulating the web page for the web browser. So what does it mean by encapsulating? Meaning the frame will be wrapped with information. So from the application layer, the data will be wrapped with the TCP information, and next when it goes down, it will wrap with the TCP information, IP information, and internet information. And finally, you will send the frame with this 4 information towards the client. And on the client side, they will de-encapsulating, meaning they will unwrap the frame, unwrap the package, okay, so that they can see the web browser. So I'll stop here and we learn about data encapsulation after this.